Hello, class, and welcome to Chapter 14, Analyzing Your Results. We're going to talk about some different types of tests, maybe some variance, variability, um, between tests, be it between and within tests, etc. So let's take a look. All right, so um, we're going to look at the different types of measurement tests that we use to test our nominal, ordinal, interval, and ratio data. So our non-parametric tests are going to use nominal or ordinal data, and then our parametric tests are going to use our interval or ratio data that we talked about earlier in our chapters. So one other test that we can also use is the chi-square test. This test determines whether the frequency of sample responses represents the frequencies we would expect in the actual population. So, how many times does a frequency show up or frequency response show up within the sample? It represents frequencies, and the chi-square test looks at um, how much frequencies are listed within our population or expected to be listed within our population. If our sample included every member of the population, we would definitely maximize possible degrees of freedom, which you should know within your statistics course that you have taken that degrees of freedom is your n minus 1. Okay, so excuse me, if I have um, an n, remember n is like the number of scores within the distribution. So if I had 10 participants, which would be my n, if I minus that by 1 because I have one group, then my degrees of freedom would be 9. If I had two groups, then it would be n minus 2, which will give me my degrees of freedom, which in this case would be 8. Okay, so if we're looking at the sample size, if every person or every member was a part of the um, experiment, we would have the maximum possible degrees of freedom, and we would know that the exact population of values of the mean and variance would be evident. So let's talk a little bit more about the sample size. Your sample size determines the degrees of freedom. So remember, I said the n minus 1 will give us our degrees of freedom. There is a different distribution for each value of degrees of freedom, which you can see listed here on this chart. The t-distribution approaches a normal curve as the sample size increases. So the more participants that we may have in the study, the larger the sample size will become, and our normal distribution will broaden and create a more evenly distributed sample size. The t-test provides a valid test of the hypothesis when assumptions like a normal distribution of the population values are slightly to moderately violated, meaning there's variances or extreme variances or shifts within the data. So we're going to reject the null hypothesis when our t is greater than 0.05 or 0.01, depending on our alpha level. So in this case, again, typically we use 0.05 in psychological experiments or research. So if I have a t that is greater than 0.05, we are going to reject the null hypothesis. So you may remember in statistics how you received your t-test or broke down your t-test and used your t-test formula. So we're not going to go specifically through this, and because we have systems such as SPSS, Power BI, Tabula, we're able to process data more efficiently with these particular data analysis software. So, but in this essence, if we were going to do a t-test, we would first calculate the t-statistics, and then we would enter it into the following formula below. So we use an analysis of variance when data are interval or ratio level, and there is at least one independent variable with 3 or more levels. So if I have one independent variable, say religion, then my 3 or more levels could be um, Buddhist, Seventh-day Adventist, Baptist, Protestant, Methodist. Those are 3 or more levels of the independent variable, and I may look at religion on um, life satisfaction. Okay, so we would use an analysis of variance, which again would be the ANOVA, our F test that we talked about in chapter 13. Because we have a higher level of independent variables or levels of independent variable that we are studying on one or more DVs. So if we're looking at within groups variability and between groups variability, within groups variability is the degree to which the scores of subjects in the same treatment group differ from each other. Whereas between groups variability, this is the degree of which the scores of different treatment groups differ from one another, or the actual grand mean. When an overall ANOVA or F test is significant and you have made no specific predictions to the outcome of your IV and DV, you may want to perform a post hoc test so that you can pair all of the treatments into groups and test them to see if there was a significant difference from the IV to the DV. So these are a few tests that we use to do a data analysis on our results. You have the t-test, you have the chi-square test, you have non-parametric test and parametric test, and you have the post hoc test as well as the F test. You may perform all possible pairwise comparisons without increasing the risk of type 1 error when you are using the post hoc test. So this is the end of your chapter 14, and I will see you in your next chapter.